Okay, I think we may start now. Hyvää uutta vuotta. Happy New Year for everyone. These are these first lessons in this online group in this course, and there may be some problems with that. Not everyone can join the teams, but I hope it won't make big problems. They are asking permissions to join the teams, and that may cause some problems or delay during the lessons. I put there again there in the chat box there is some area maze or area puzzle if you want to do that during solve that problem during breaks or waiting time. Okay, now we will start this course, and I will show. Okay, there is some permission. Let's take this again. I will share my screen there if I can get the right one. I hope you can see my Moodle page right now. Vectors and matrices. I will translate that in Finnish language soon when I start my teaching actually. But I will show the Moodle page at this point. This looks like or it will look like very similar as in this course in autumn algebra and geometry. So this is not so I don't know perfect what that Moodle page looks like. It's only some kind of a place where you can find some materials from this course. So I have added the schedule for the course. I have this kind of color system there. These I think they are red or pink. I don't actually can't find out which is the correct color there, but almost red color, that means online group, and then these blue colors, that means campus group. And actually I don't know how many of you are at this moment in Finland, but you may join both groups if you like. I don't care in what group you are joining. So if you have possibility to join the class in campus, then you are very welcome there, but you may also join these online classes. I will probably arrange this course quite similarly as in autumn course, so that mostly during these online lessons I will go through some examples concerning vectors and matrices, and I try to find also time for independent calculating during these lessons, so I can help if you have some problems or you don't understand how to solve these problems, which I will give during the course. And then during these campus lessons, I mostly probably, I'm not quite sure, but probably I will do so that I will prepare some PDF files which I will add to Moodle, or or share in that classroom in campus, Seinäjoki campus. But those files will be also here for you. So this material is the same for both groups. And I also record these lessons, which I both in online and and in campus lessons, as I did in autumn. But probably during campus lessons I will not make any. I will not have any actual teaching. I will only be there to help students in that classroom. And these online lessons I will have either at my home office, as now this messy room is my home office, and or in the if I am at Seinäjoki during online lessons, I will have these lessons in that studio room there as mostly during autumn. But in this period, January and February, I mostly have Friday lessons. Friday days. Distance dates. I don't have to drive to Seinäjoki, so mostly during Fridays I will have these lessons from my home office. But I don't think that is not so important. I have well my documentary camera is better here at my home office than in Seinäjoki campus. I was tired of that poor quality of that documentary camera I had to use in Seinäjoki. So I bought years ago my own documentary camera, and this is a little bit better. This has a little bit better quality. So as I told in email, there is a possibility to as you see probably here from this Moodle page, in campus group I will arrange an exam for mostly for students who have earlier studies concerning this course, and they can pass the course by doing that exam. But unfortunately I can't arrange that for online groups, so only in classroom in Seinäjoki it is possible to do that kind of exam. But I think there may be some students who will pass the course during that first exam shown next Monday. I will arrange that exam, but that is not necessarily. But I guess that many students still want to complete the course by doing these assignments as we did on autumn at algebra and geometry course. We will have the same habit in this course also. I try to prepare 30 assignments during the course, and then you have possibility to pass the course or get any grade you want by doing those assignments. I think most of you have already done those assignments on this course, algebra and geometry, last autumn. And if you have this personal number for doing those assignments, I will keep the same numbers during this course, so you don't necessarily need to ask a new number, just you use the same. I think there may be some problems with the voice there. There was some message that I was hope it will be okay now. Yes, now I forgot what. I don't know. Can you hear my voice all the time? Because I get messages that I am muted. No sound. You can't hear anything. How about now? Can you hear now? Okay. Now, can you hear? Yeah. Did you hear anything? I was talking. All the time. Oh, 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 okay. I don't know what happened because I didn't. Oh, I don't understand why did that happen because I didn't touch anywhere. Yeah, but thank you for telling me that. Yeah, so this exam will be for campus group and but also you have possibility to do those assignments during the course. This course actually it has a schedule that it ends. If you see the Moodle page here, it ends. I can't show you because this is some problems here. Yes, now it ends at the week 8, but actually it doesn't end. Only these lessons end at week 8, but this course you continues so that you have time to do those assignments to the end of April. So there are still 2 months after this end of these lessons you have time to do those assignments. And also if you want to continue doing those assignments during autumn course, then it is also possible. So it is not over that course either. Well that end of April is very. I hope you have done everything at during the April, because on May and June I am not on holiday yet, but I have lots of things to do which I have not time during this year. So I probably don't have so much time to check those assignments. So it is in your own well-being to get those done before the end of April. Okay, and then we have this in this course or Moodle page. Here are the completing course instructions, how to complete the course. So this is exactly the same as in earlier course you had in autumn. And then there are right now there will be also the same kind of Excel sheet there, which you get those assignments. So everyone has the same problem to solve, but different starting values for the calculation. And then I will add video recordings. For example, this video I'm recording right now, I will add these to the Moodle page. Mostly these lessons will be So I think every lessons will be so that they are my last lessons during that day. So after these lessons, I have time to prepare those videos, those YouTube videos, and add them to the Moodle page. And I think they will be there. I don't know, maybe after 1 hour of the lessons, after the lessons. So if you can join the online class, you may watch those lessons later. And then there is this part of study material for vectors and matrices. Right now there is only some kind of exercise sheet page there, and also one PDF file which I have not done myself, but it is done by earlier teachers of this course, the same teachers as were during this algebra course in autumn. They have these teachers. They have a different way to complete this course. So the material is not exactly the same which I will use. But I think it's good to study also those materials there. There is not yet ready. There is only a little bit material for vectors, but not that all for matrices right now. But I will add that material there during the course. Yes. Okay. Let's change the view. I think you can see this right now. Vectors and matrices. This course name in Finnish, there is also the same course for Finnish students, and it is very easy to understand the course name which you see in Finnish, because all many times Finnish words we get from English words by adding the I letter to the end of the word. So for example, this vectorit and matrices in Finnish, it is. I don't like this. I bought some new pens and now I noticed that they are not good pens at all. In Finnish, vektorit ja matriisit. Vektori is vector and matriisi is matrix. And in the plural form, vektorit, matriisit, this the end means that it is the same as in English, this S ending, vektorit ja matriisit in Finnish. If I show something from my formula book, this is unfortunately Finnish book, but I will show something which kind of material we go through. This is vektorilaskenta, is the title there in Finnish. In English it is vector calculation. And we will go through some concepts concerning this vector calculation. There are the notations and the calculation rules. For example, in this page we have sum and subtraction rules and multiplication rules, and then there are some other material. We will also use these, and then we have also materials or rules for vectors which are in three dimension, third dimension there. So there are some calculation rules which we will use. And then this matrix part, I will also show something from this formula book. We have actually we had these determinants already during the algebra and geometry course. Determinant with 2 rows and determinant with 3 rows. We had those already. But then we have these rules for matrices. So you can see those are that kind of tables. Those matrices. There are some, and there are some multiplication rules there, and also some concepts which we will have to. Unfortunately, this is in Finnish, but I will give you English notations and English names for those concepts during this course. And then we will get some applications also for these two concepts, vectors and matrices. So first we try to find a better pencil, because this was a disappointment. I don't know why did I find those bad. This is probably better. Let's first take two concepts, scalar quantities and vector quantities. Scalar quantity in Finnish, we can call this skalaari suure. This quantity is suure in Finnish. And those are mostly simple numbers. They can be examples. They can be simple numbers, 5 or 6 or pi, whole numbers, or of course this is also scalar. These are simple numbers. They have no units. But of course they can also have units. For example, we may have 5 meters, 6 seconds. We may have, for example, this pi can be an angle in radians. So it may be, for example, pi radians. And for example, this 2 thirds, 2 divided by 3, it may be, for example, time. It may be, for example, 2 thirds of hour. So these scalar quantities, we know scalar quantity if we know the magnitude or the value and that possible unit. This is exactly known. If we know that distance is 5 meters, we know exactly everything of that distance. It is 5 meters. This is distance. In Finnish, etäisyys. And also etäisyys. Also, for example, 6 seconds. It is a time. And it is also exactly expressed if we know the value of time and the unit of time. In Finnish, aika, time. And this was this angle. In Finnish, kulma. Oh, this is also time. I didn't notice. This is of course also time. This hours there. And these are concepts which we have used earlier, for example, during this algebra course and algebra and geometry course. We had their numbers and we had their distances, and we had angles there. I don't remember. Yes, we had also times there, because I think one assignment was number 7, probably, if I remember correctly. It was a problem where you had to solve the time consumed by an object to go some course there. I don't remember what was there. It was some linear moving there, and we had to calculate the time, how much it took to go past the course there. Okay, and then the other quantity is vector quantity. And in Finnish, vektorisuure. So I will write again here, because I forgot that in these scalar quantities we need to know magnitude and unit. This magnitude, by the way, in Finnish it is suuruus, and unit is yksikkö. Or unit, or we may also call dimension. But this vector quantity, it is not enough to know the magnitude, because we have to know also the direction. For example, we may have, for example, a moving object which moves, for example, a car which moves with the speed, for example, 60 kilometers per hour. It may be 60 kilometers per hour to, for example, northeast. So this velocity here, it is not enough to know what is the speed. We need to also know where, in what direction we are moving. Or if we have, for example, I think some of you have already had the mechanics course in this university, and some probably have it right now. I'm not quite sure. But there you are calculating with forces, and we may have, for example, force, for example, 5 kilonewtons upwards. If we draw that with 5 kilonewtons upwards. So it is not enough to know what is the magnitude of the force, 5 kilonewtons. It is not enough, because we have to also know in what direction is that force. I think you will have also, I'm not quite sure, but some of you probably do have the statics course. I'm not sure if it is in this academic year or the next one, probably next one. So in this statics course you also calculate with forces, and there will be also moments or what else. And they see these moments and these forces, they are both vector quantities. So in this case we need to have magnitude, unit, and direction. This direction in Finnish, it is suunta. I don't know if I have, wait a minute. These compasses, or here I have some compasses here in, this is Finnish compass. Probably you can see the name of that compass. It is suunto. The what is that called? That firm which makes these compasses, it is called, the name of that the, now I black out what is the name of the in English, but it is called suunto, the factory that makes these kind of machines. So that comes from this suunta, direction, and it is easy to understand that this gives you some kind of direction. Okay. And also displacement. For example, you may have some object which moves with some velocity, and it changes the place. So we may have, for example, displacement, for example, 2.5 meters to the right, for example. So this is displacement. In Finnish, we may call that siirtymä. To move. One word for Finnish, in Finnish, for word to move is siirtyä. To move, siirtyä, and displacement is siirtymä. It means the amount of the moving. Yes. So let me take a grid paper. It is easier to use this. Let's take an example. how do we notate these vectors? For example, if we have XY coordinate system here, I will draw those coordinate x's here. I hope you can see that. X and Y, X ja Y in Finnish, X, Y. And we have this origin of the coordinate system. We mostly call that point or notate that point with O letter, or you may also think that it means 0. Origo, origin. Let's put that in. I don't know if we had that already in. Origin, or in Finnish, origo. Well, at this point we don't have this I ending with that word. And let's see, for example, we have here a point here, and let's call that point A. And the coordinates for this point with this grid paper, I can calculate that it is 1, 2, 3, 4, 5, 6, 7. This is 7, and here we have 3. Those so small numbers. Let's put a little bit bigger. And we have this A letter here, so the coordinates for this point is 7, 3, if we have X in the first place and Y in the second place. And now we make a vector by, let's take a red color, by using my ruler here and end there. Right now, this line I draw there, this is line segment. I will let's write it here below the picture. OA, this OA here is line segment. In Finnish we call this, actually I don't understand this Finnish word because it is very strange name. I don't have any idea where someone have found that name, because it's really, well, actually maybe it is a Finnish word, but I don't understand why this is called with this name. It is in Finnish jana. I many times wonder this word, because this tells anything. This does not tell anything for a win, this word, jana. We have a Finnish name for girl, Jaana, which has two A letters there. My sister is Jaana. So, but this is with one A, Jana. So simple OA. This is a line segment, or Jana in Finnish. But if we add an arrow there, now it becomes a vector. And the notation for vector is similar as this line segment, but we use this arrow. This is vector. So this arrow here, we may also write it here, OA. So when it was a simple segment, line segment, all it could tell us was the place there and the distance between the points. Many times, for example, in triangle problems, we use this line segment notation. OA means for example, in a triangle from the point O, the distance from the point O to point A. OA, that is the line segment. But when we add the arrow there, then we have this direction, and now it becomes a vector. This may tell us that we have some object which starts from O and it goes from this line to the A. Or it can also tell us that this object starts with O and it goes some route here and it ends up to the letter A. And the total displacement there was this OA. Well, this arrow here in the above this OA or this segment notation, it is many times so slow to write that many times we skip the arrow there, but other notation we may also use a simple line there, so without that arrow there. So we may also draw it like this. This tells us the same thing. And mostly I use this notation because it takes time to always write that arrow there, because we can understand that if we have this horizontal line above that segment notation, then we understand that it is not a segment. It does not mean any length or distance. It doesn't mean that, but it means vector. It means some kind of displacement from the point O to point A. This vector notation may also this graphic picture from this vector, as I told, it may mean or express some displacement, but it may also tell us that there is some force which is attacked to point O, and it is the direction of that point of that force is the direction from O to A. Or we may also think that the direction is such that it goes 7 units to the right and 3 units to the up. So 7, 3, and that gives us the direction. So for example, we may have, for example, this my compass here, and we have some force which is attacked at that point of this object, and then it tries to move that object to this direction. We may express this vector here in this my example with a similar way as we use the coordinate, as we express the coordinates of this point A. So, for example, this OA here, there are many ways to express that vector with numerical way. One way is to use almost exact the similar way as this coordinate but we will use not these parentheses or brackets, but these brackets. This is one way to tell the difference between the coordinates of a point and vector. This means only this 7 and 3. This means only the coordinates of that point. But this expression tells that we have a vector which have a direction of 7 and 3. 7 to the right and 3 to up. Also, we may use actually this is some kind of matrix notation, but we don't have to know it yet. But many times we may use this also this kind of way. This is actually called column vector. Or then we may also use so kind of unit vectors. I will first write the notation here and then explain what I mean. We may also use this kind of method. We tell that we are moving 7 units to the direction of x-axis, and some you used to use this notation. Actually, I don't use this, but I will write this because probably some of you are used to this. We use x here, but not simple x, but we use this kind of accent mark there, 7x, and then plus. So this tells that we are moving 7 units in the direction of x-axis and then 3 units in the direction of y-axis. This notation is used, but I think at least in Finland we are used mostly with this notation. We don't use x and y, but we use I and j. So we will use I here and y here. And let's take those here. Note y is a unit vector. Unit vector means in this case that it has a length of 1 unit. And the direction for this I vector is to the opposite, the same direction as has the positive x-axis. So I is a unit vector in the direction of positive x-axis. This unit vector means that length is 1 unit. Sorry, this has nothing to do with that. And the same holds with this J here. This J is a unit vector in the direction of positive y-axis. So actually this tells us, if we are using this 7i plus 3j or this 7x plus 3y, this tells us that we are moving 7 units in the direction of x-axis and 3 units in the direction of y-axis. So if we are starting from this point and we start moving 7 units to the direction of positive x-axis, we will go 1, 2, 3, 4, 5, 6, 7. We are at this point right now, and then we move 3 units in the positive in the direction of positive y-axis, and positive y-axis is in this picture to the upward, so we will go 3 units upward, so we will end up to the point A. So this tells us the displacement. And we also, when we are having three-dimensional vectors, we have also this third dimension there, and I will add it also here. So we may have k, ijk, and this is repeating, repetitium mater studiorum est. Repeat is a mother of studies. How do you translate it in English? It's a unit vector in the direction of positive z axis. So we may say that for example in this case, in this example I have here, so this means that this I vector, it is the same as 1, 0 if we use this column vector notation, or if we use this notation here. And this is for the plane two-dimensional vectors. This is two-dimensional vector. But if we have this third dimension there, then we will add some 1, 0 there. So we may also tell that this I equals 1, 0, 0 or 1, 0, 0. And this is 3D vector. By the way, in Finnish word, this dimensional, two-dimensional and three-dimensional this is in Finnish kaksi. Well, two is same as kaksi, and ulotteinen. kaksiulotteinen, two-dimensional. And then the same with three-dimensional. I will add these Finnish concepts because of many reasons, but one reason is that maybe I will add some materials in the course page there, and there sometimes maybe some Finnish problems there, so it is more easy to understand if you are used to some Finnish concepts. Actually, in Finnish we don't say this kolme-ulotteinen, but kolmi-ulotteinen. Three is kolme, but in this case, when we are using three-dimensional word, we say it kolmi-ulotteinen. But everyone understands if you use kolme-ulotteinen. It is very easy to understand for Finn what you mean. So no problem. Okay, then let's have a break now. I will have to save this recording, so let's have a 15 minutes break right now. I will add the time when we will continue.